So today we are starting with our revision work from units and dimensions, which is the first chapter of class 11. So when we talk about units, there are two such type of units. One is fundamental and one is derived. The fundamental one is something that is not made, something that is already there, and we are just observing that particular measurement. For example, length. Length is a measurement. Mass is a measurement. Time. So these are not being derived. These are a given quantities. And then you have another type of unit known as derived. That uses one or two units. For example, velocity. Velocity is what? Meter per second. So meter comes under length, second comes under time. So these are known as derived, and the fundamental ones that are already there. Length, mass, time. And derived are the ones that uses one or two other fundamental units to make up its own unit. One is velocity, another example can also be your acceleration, and so on. So there are three types of system. You have FPS system. F stands for foot, P stands for pound, S stands for second, and CGS centimeter gram second. MKS, the famously used type of system is MKS, where we use meter, kilogram and second as time. So out here there is one particular way of dealing with conversion of meter to foot. Although this is not precise, but this can be worked out. As 1 meter to be equal to 3.3 foot. Also 1 kg is equal to 2.2 pound. If we want to convert MKS into FPS, this can be very much useful, whereas in case of time it is always the same. And then coming to your fundamental units. So fundamental units has been written in this form. Okay, these are the fundamental units, whereas the last two is also coming under the fundamental unit. Mass denoted by the letter M. Okay, this is the symbol. T, time, T for time. Okay, this is the symbol for time. Length S, L. These are the three most commonly used. And we have current. The unit of current is ampere. Therefore, we are using this symbol A. Temperature, although temperature can be written as T, but since it has already been gone, it has already been assigned to time. Therefore, we take temperature as K, Kelvin. Okay, this is just a symbol to solve some numericals, to come out with some dimensional formulas. Okay, K. Amount of substance, mole, in terms of mole. Okay, this is the symbol for amount of substance. So this is mole. Luminescence intensity. Okay, that is candela, and its symbol is C. Now let us look into some famous dimensional formulas of this quantity: speed, area, density, force, gravitational constant and potential. In case of speed, we know the formula of speed to be distance by time. Okay, out here M is not present, L has the power 1, time is not present with respect to the numerator. There is no time, it is dealing only with the length. In the denominator, it is dealing only with the time. Therefore, the dimensional formula for speed is LT inverse. Same with area, length into breadth. Since it is dealing with what? Length, therefore L square. And then density. Density is mass by volume. Mass in terms of kg, volume in terms of meter cube. So this is kg. It has only the unit of mass. And this is length. It has only the unit of length, L cube. Therefore ml to the power minus 3. This is the dimensional formula for density. Coming to force, it is mass into acceleration. It has the dimension of mass to the power 1, L to the power 1, T to the power minus 2. This is coming from meter per second square. which is the unit of your acceleration. Okay, L t to the power minus 2 is coming from the unit of acceleration, m to the power 1 is coming from the mass. And then you have gravitational constant. The mostly asked question in case of NEET exams are from gravitational constant, Planck's constant, and so on. So in case of gravitational constant, you need to remember this formula: F is equal to G m1 m2 divided by r square. Okay, keep this gravitational constant out here, and then do all the necessary things. Okay, this is force, therefore it is what? Kg meter second square. This is kg meter second square, and this is r square. This is what has the unit of length, therefore meter square. And then mass m1 m2, this is kg, this is kg, therefore kg. This F is force, is which is the formula for force is kg, sorry, the SI unit of force is kg meter per second square, and then r square in terms of m square, m1 m2 kg into kg. Okay, therefore the dimensional formula for gravitational constant can be written as m to the power minus 1, L to the power 3, T to the power minus 2. And then lastly, we have potential, which is given as V is equal to E by Q. Okay, V is equal to E by Q, which can be written as M1 L square A1, this is for current. Okay, this T to the power 1, and then you have T to the power square. And when we do all the thing, the dimensional formula for potential can be written as M1 L square T to the power minus 3 A minus 1. Out here, this E is the energy, Q is the charge. So energy can be written in the form E is equal to half of mv square. Okay, this m is out here, mass, and then this v square has the dimension of L T inverse whole thing square, and this becomes L square divided by T square, which is here. L square and T square, they are here. Therefore, and this Q is given as I, current, is equal to charge per unit time. Therefore, Q can be written as IT. I has the unit of ampere A, and T is the time. Therefore, T is present out here. So this is for Q, and this entire thing is for E. Therefore, when I do the necessary calculation, then I get the dimensional formula for the potential to be m to the power 1 L to the power square T to the power minus 3 A to the power minus 1. Another topic, we have principle of homogeneity, which is a extremely important topic in case of units and dimensions. This principle of homogeneity helps us with the most important thing that is required in order to understand a formula, given formula, is it correct or not. So out here, this particular formula, which is quite famous, V is equal to U plus AT. Okay, using this, let us see, is it dimensionally correct or not with respect to the dimensional analysis. So this is LHS, this is RHS. LHS, we already know that velocity is what? Meter per second. So LT inverse, LT inverse, and then right hand side, this is what? U. U is already, this is having the unit of velocity. Since this is initial velocity, this is final velocity, this is going to have LT inverse. This is LT inverse. Out here, this is L T to the power minus 2. This is acceleration, meter per second square. Therefore, L T to the power minus 2, and this is what? T to the power 1. Therefore, here 1 gets cancelled out. Therefore, the unit of this AT becomes L T to the power minus 1. So in the left hand side you have LT to the power minus 1. In the right hand side you also have LT to the power minus 1. Therefore LHS is equal to RHS, which means that yes, this particular formula is dimensionally correct. And then V square is equal to U square plus twice AS, where V square is your final velocity, U square is the initial velocity, plus 2 into acceleration into distance. Out here, this has what? Unit of L square, T to the power minus 2 square. Okay, this also has the same thing, L square, T to the power minus 2 square, whereas this has L, T to the power minus 2, and this has L to the power 1. Okay, this is distance, therefore L to the power 1. So L to the power 1 and L to the power 1 from both this is going to get added up, therefore you get L square to the power minus 2. So even this formula is dimensionally correct, since the left hand side is equal to the right hand side. Apart from the previous situation, the questions can also be in this term, okay, where V can be written as is equal to A plus B divided by T plus C to T to the power square. From here they can ask what is A, what is B, and what is C. So in order to find A, put all this equal to 0, B and C is equal to 0. Therefore the dimension of A is going to be what? The dimension of V itself. Okay, if this is 0, this is 0, the dimension of A can be taken to be the dimension of V itself. And then in order to find B, make this equal to 0, this equal to 0, therefore B can be taken as Vt, okay, where V has the dimension of L to the power T, and T already has the dimension of this is plus 1. Okay, so this gets cancelled out, therefore you are left with the dimension of only L in case of B. And then in case of C, make this 0, make this 0, therefore it can be taken to be Ct square is equal to V, okay, where C is V divided by T square. And doing the necessary dimensional analysis, in this case you get the dimensional formula for C to be L T to the power minus 3. You can get questions based on this type of analysis as well. Now another thing is that SI unit of force to CGS. The SI unit of force in case of MKS is Newton, which is also kg meter per second square, okay, whereas in case of CGS it can also be taken to be dyne. In case of MKS we take it Newton, in case of CGS we take it dyne, where CGS is what? Centimeter, gram and second. Now break this Newton, it becomes kg meter second square is equal to x. Take this as x for a while, okay. Kg is how much in terms of gram? It is 10 to the power 3. Kg is 10 to the power 3 in terms of gram. Whereas in case of meter, converting meter into centimeter is about 10 to the power minus 2. Okay, this is how meter gets converted into centimeter. 1 divided by 10 to the power minus 2. So I am taking the 10 to the power minus 2 to the numerator, it becomes 10 to the power plus 2. Putting this in the numerator, it becomes 10 to the power plus 2. And second square, the way it is all the time. Okay, so therefore doing all the necessary calculations out here, this is 3, this is 2, therefore the answer becomes x is equal to 10 to the power 5 dyne. Another topic, we have something known as significant figures. In this significant figures, it becomes a little important while doing some calculations. For example, out here, all non-zero numbers or the zeros occurring between two numbers, okay, between two non-zero digits are significant. For example, out here x is 1 2 3 4. All these 4 numbers, okay, related to this x are the significant figures. Therefore in this case there are 4 significant figures. And then this, taking the help of this particular statement, okay, zeros occurring between two non-zero digits, this is 1, this is 7, so 0 out here is in between. Therefore this 2 zeros can also be taken to be significant. Hence you have 4 significant figures out here relating to this x. And then here x is equal to 0.005704. Here this 0.00 are non-significant. This zeros, okay, any zeros occurring to the right or any zeros occurring to the left without being in between the numbers, then those are insignificant numbers. Those zeros becomes insignificant. Therefore, you take only this 4 into consideration and it becomes 4 significant figures. And then another one, x is equal to 3210. Out here, as I told you, any zero on this side or this side is going to be taken to be non-significant. Hence, it has only 3 significant figures. And then in decimal point, okay, trailing zeros are significant. For example, out here, 3.5, this zeros after the decimal point, okay, this zeros after the decimal point are taken to be 4 significant figures. These are taken to be some significant numbers. That is after the decimal point, not before the decimal point. Okay, so this is your 4 significant figures. And then you have errors. The most important questions has been asked from errors. Okay, so in case of error, whenever we do any kind of calculation, there is always some kind of error. Error is always being involved in any such type of reading. Okay, we cannot proceed with errorless quantities or result. Okay, errors are always present in any kind of experiment that we do. Okay, so errors, we deal with errors as true value. What is the true value? And the measured value, the value that you have measured. Okay, the quantity, for example, if you try to measure the length of this pen, okay, the true value, suppose if it has been provided to you by the seller, the length of this pen, the true value has been provided to you by the seller, and now you want to calculate, is it accurate or not? So on doing so, true value, okay, and minus your value, whatever value you are going to get, minus that value, okay, it becomes your calculation for error. And in order to calculate errors, in case of units and dimensions, you have certain ways. For example, mean value, calculate the mean value first, then absolute error, relative or fractional error, and then finally percentage error. So whenever we do the calculation of anything, we do not take the reading only once. We do not take the reading only once. We take the reading once, twice, okay, 3 times, 4 times, n times. As many times as we want, we take the readings. Therefore, here A1, A2, A3 are representing that, and n is going to take that is the sum of all this. And then you have absolute error, okay, that is A mean. You take the mean of all this, okay, divide by n, and then this can also be remembered as absolute mean error. Okay, absolute mean error. Okay, and then you can take this as absolute error. Then you have something known as relative error, which is nothing but absolute error divided by A mean. Okay, absolute error divided by A mean. And then you have percentage error. Percentage error can be represented as relative error into 100%. Okay, again, mean, that you do the calculation, then you have absolute mean error, okay, out here, and then you take the absolute error as A mean, whatever you are going to get out here, and then this A, and then relative error is given as the absolute error divided by A mean, and percentage error is given as relative error, this quantity, into 100. Okay, you are going to understand this with some examples. Okay, you are going to understand this very easily with some examples. Okay, let us have a look into this particular question. An object was weighed by a physical balance and following readings were obtained: 5.04 grams, 5.06 grams, 4.97 grams, 5.00 grams, and 4.93 grams. So the question follows that find the mean value, mean absolute error, relative error, and percentage error. Okay, these are the errors that you need to find. Therefore, start with this. Okay, take the mean of this 1, 2, 3, 4 and 5. Take all these values. Okay, where 5.05 can be taken as M1, 5.06 can be taken as M2. Remember, these are the different readings of the same thing. Okay, to find the errors. So, and then divide all this by 5. Since there are 5 quantities, divide all this by 5. Therefore, you get M to be 5 grams. Okay, on taking this, the mean of this, you get M to be 5 grams. Now apply absolute error. Okay, now apply absolute error. You have found the mean. Okay, what you do in this case, with respect to the mean, take this. Okay, with respect to the mean and start doing the calculation. This will be your mean 5 grams minus M1. M1 is 5.04. Okay, although it is a little, this quantity is more than what it is out here. Okay, this quantity is more than what it is out here. Therefore, you might think that this should be negative, although this is inside mod. Please remember, this is inside mod. So anything after mod will be taken as positive. Okay, therefore the error in calculation from here, okay, this minus this is this much, this minus this is this much, this minus this is this much. Okay, and then this minus this is this much, this minus this is this much. Okay, you got the value of all this, and then now calculate this. Okay, where you get, take all these values, divide by 5, you get 0.04 grams. Okay, as mean absolute error, and then take this 0.04, divide by 5. Okay, take this 0.04, divide by 5, and then you get it as plus minus 0.008. Okay, and then as I told you, what is percentage error? It is nothing but taking this quantity into 100. Okay, percentage error is relative error into 100. Okay, therefore the error in the calculation of this quantity, okay, if this quantity of that particular object, of which, the measurement of which object was going on for the mass, okay, the error is found to be 0.8%. Okay, the error is found to be 0.8% in the calculation while calculating the mass of that particular object. Now, with respect to errors, we have addition, subtraction, multiplication and also division. In case of addition, if I have been given A is equal to B plus C, okay, and I have been asked to calculate A, okay, so in this case, B is given to me 2 plus minus 0.1. C is given to be 3 plus minus 0.2. So out here you can easily figure out what is the error. This is the error. Okay, in case of B, the error is 0.1 plus minus 0.1. In case of C, the error is plus minus 0.2. Okay, these are the errors, and the error is represented in case of B as delta B, that is error present in B. Delta C is the error present in C. Therefore, delta B is 0.1, delta C is 0.2. Therefore, A can be taken as, the value of A will become 5.3. Out here, the maximum error is 3.3. Okay, the maximum error is 0.3 is the maximum error. And please always remember, errors are always added up. Errors are always added up, not subtracted. Now, talking in terms of subtraction, this can be taken as, okay, this delta A is the error in A, delta B is the error in B, delta C is the error in C. Okay, so out here B is given to be 2 plus minus 0.2, C 1 plus minus 0.1. So out here again, as I told you, errors are not subtracted, they are added up. Therefore, this again becomes 0.3. So the maximum error out here is 0.3. Hence, note, errors are always added. Okay, and then multiplication. A is equal to B into C. In this case, what we do, we make use of the fractional error. Okay, fractional error, it is a trick. So out here, what you do is, this quantity can be taken as error in A divided by A. Okay, error in A divided by A is equal to B, error in B divided by B, plus, okay, plus error in C divided by C. Okay, plus error in C divided by C. Okay, this is how, this is tricks that can be used to solve the given quantity very easily. Okay, and then division. Although this is what, A is equal to B divided by C. Okay, if I take this C in the numerator, it can be taken as B into C inverse. Okay, and then if you get this much quantity, you just use this fractional error method. Okay, where A can be taken as delta A divided by A, B delta B divided by B, plus this minus sign is going to come here. This minus sign is going to come here, although it is inside mod. So once this minus sign comes outside, it becomes positive. Okay, delta C divided by C. So power, and then you have, after division, you have power, where A is equal to B to the power square and C to the power cube. Okay, this becomes delta A divided by A, B. This square comes in the front. Okay, therefore this becomes twice delta B divided by B, plus 3 comes in the front, 3 delta C divided by C. Okay, so let us take up one such example, this one. A is equal to B C square divided by root over D. Okay, this is what, delta A divided by A. Okay, and then what, this is B, delta B divided by B. 2 is going to come in the front. Okay, delta C divided by C, plus mod. Okay, plus mod, since this D, when it goes to the numerator, it becomes D to the power minus, okay, minus 1 by 2. So minus 1 by 2 is going to come to the front. Okay, it becomes delta D divided by D. As I told you, once this minus comes outside of the mod, once it comes outside of the mod, it becomes positive. Therefore, this can be taken as 1 by 2 delta D divided by D. So let us have a look into another such example. Derive an expression for the time period of a simple pendulum. Okay, out here this question is wanting to tell you that, you know, I have a pendulum. Okay, I have a pendulum which is going in a swing somewhat like this. Okay, and I do not know what is the formula for the time period. How much time is it taking? Okay, all I know that the given physical quantities to me is it can depend upon the mass of the bob, it can depend upon the length of the pendulum, and also upon gravity. Okay, now taking all this thing into consideration, let us write T is equal to m to the power A, that is mass of the bob to the power A, length of the pendulum to the power B, and acceleration due to gravity to the power C. Okay, therefore this T becomes is equal to K, where K is the dimensionless constant. Okay, dimensionless constant. So this T has the dimensional formula of T to the power 1. Okay, this is 0, this is 0 to the power 1. Now M is mass, m to the power A. Okay, m to the power A. L, length to the power B. And G is acceleration due to gravity, which has a dimensional formula of L t to the power minus 2. Therefore, L t to the power minus 2 into C. Okay, this quantity inside the bracket into C. So therefore, when I remove the bracket, it becomes MA, LB, L into C, T minus 2 into C. Okay, T minus 2C. Therefore, this L and L are common. Therefore, L will be B plus C. Okay, L will be B plus C. So from here, what we do, we try to find out the value of A, B, C. Okay, we try to find out the value of A, B and C. And on finding the value of A, B and C, we'll come to a particular given formula. Okay, that has to be dimensionally correct. And then put A is how much out here. A is from here. Okay, M is A. Here M is 0. Therefore, A will be 0. Okay, L is what? B plus C. This L is 0. Therefore, B plus C in this case will be 0. Okay, let us take this. Okay, the given quantities for which the calculations will be less, we take those quantities first. It becomes a little easy. Okay, so T to the power minus 2C. Here T is what? To the power 1. Therefore, minus 2C will be equal to 1. Okay, therefore C will be is equal to minus 1 by 2. And then take this B plus C. Since C now is known to us, C is now known to us, therefore B plus C will be equal to 0. C is how much? Minus 1 by 2. Therefore, B becomes 1 by 2. On calculating, what we are going to get? A to the power 0, okay, C to the power minus 1 by 2, and B to the power 1 by 2. Then putting all this power in M, L and G. M is what? A has the power of 0, therefore M is 0. L is B. Power of B is how much? 1 by 2. L is 1 by 2. G has the power of C. C is how much? Minus 1 by 2. Minus 1 by 2. Therefore, time period formula can be written as T is equal to K root over L divided by G. On calculating for G, which is the dimensional constant out here, so K is nothing but 2 pi. Therefore, the formula for the time period of oscillation of a simple pendulum is T is equal to 2 pi root over L divided by G. So as we had discussed earlier that we can find out whether the given particular formula or given particular said physical quantity is it correct or not using dimensional analysis. Okay, so let us have a look. Pressure is defined as momentum per unit volume. Someone has just stated just like that pressure is defined as momentum per unit volume. Is it true? Take the help of dimension. Here momentum per unit volume, okay, momentum is what? P is equal to mv, mass into velocity, and volume is v. This is mass, m to the power 1. V is what? L T inverse, and volume is nothing but meter cube. Okay, meter cube, which is L to the power 3. Therefore, you have m to the power 1, L to the power minus 2, T to the power minus 1. This is the dimensional analysis of momentum per unit volume. Okay, and then taking pressure, the original formula of pressure, and trying to find out what its dimension. Okay, dimensional analysis, and on doing the necessary calculations for pressure, we find that pressure is what? Force per unit area. Therefore, putting the dimension out here for force and area, we get m to the power 1, L to the power minus 1, T to the power minus 2. Okay, out here this is not matching with this. Therefore, no, as it is not dimensionally true. Okay, therefore the answer for this particular given question that someone said momentum is pressure is what? Momentum per unit volume is wrong because it is dimensionally not matching.